All right, guys. So today we are moving past our angle relationships and moving into our triangle relationships. So we are working with we're going to learn a couple different rules today, and then we're going to learn how to apply them on Thursday, just like we did last week with the angle rules. We learned all the definitions and stuff, and then we learned to apply them on Thursday with the example problems. We have a good bit of example problems built in as well as planned for Thursday. So I'm going to open up our slide to the correct slide, and we're going to kind of zoom in here and begin. So triangles and angles, kind of how we're related, how they're related, and how working with them kind of works together in this unit. So triangles, just to go over basic labels of stuff, we do have angle A, B, C, typical letter-based names for angles. You also can see something if it's labeled with a 1 or if it has that little hoop mark with it, that is referring to that specific angle. So that is how you could mark an angle. You can label it with a number, a letter, smiley face, anything. X, that seems to be the math teachers go to. And we also have our segments or our sides. We have AB, CB, and AC or CA. Doesn't really matter which order they're in regards to line segments. But we also can rename lines or name lines that we don't have labeled. So we could look across from this angle and say this is line A because it's across from angle A. Angle C is across from line C. Angle B gives us line B. Those are lowercase, A, B, and C, not uppercase. Angles are typically noted with uppercase letters. So triangles, 3 sides, 3 angles, kind of easy to point out there. With angles, it can be a little bit different. It can be a little tricky. So right here we do have our different angles, and we move on to, instead of just saying angle B on this, because it could be 2 different angles, because this one is noted, this one would be technically considered angle B. But this is also angle B. We move on to labeling them more like this with a sequence of letters. So we have angles A, B, and C, as well as angles D, B, and C. That just tells us which, are we looking at this obtuse angle, ABC, or this acute angle, DBC. We also have our rays, or they could be segments, or they could, whatever lines, whatever they are, like AD is a line, BA is a segment, BC is a segment, BD is or not a segment, array, but they could be segments. It really just depends on what's on the end. We're not going to spend too much time talking about that because we should already know kind of that stuff from before. We also have point, A, B, and C, and D, A, B, C, D, to help us label everything else. That is how we label and name triangles and angles. I realize some of us didn't know that, so that's why that was added in to our notes. So we have our missing pieces, postulates, rules, theorems, blah, 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 blah. So our main goal in the first half of this unit is to use what we know to find out what we don't. That being said, some of the stuff that we talk about today is going to be very simplified and very like, well, duh, Miss Monroe. That's okay. That's the point. We're going to use it in more advanced ways in a second. So missing pieces, postulates, rules. We have a couple different theorems and ideas. So this first one we're going to talk about is our segment addition theorem. It tells us segment AB is divided by point C. My window just like flung open. That tells us right here. Actually, I'm going to make it yellow. Segment AC and BC added together make AB. This part plus this part equals the entire thing. Mind-blowing, I'm sure. And this holds true for every line that is segmented off into parts. So AC plus BC is AB. Yep. If you can understand this, you will do fine today. So our examples are if segment 5 or if segment AB is 5, AC is 5, and segment BC is 8, then segment AB is 5 plus 8 to give us 13, because this side plus this side gives us the entire line. Then we have problems like this, where segment AC might be an expression. It may not be just a number. Segment BC is 30 and AB is 40. So the entire thing is 40. AC is 2x plus 10. BC is 30x, or 30. So I went ahead and wrote that. Oops, we can change our color back to orange here. Then I have 2x plus 10 equals 40, because I added my negative 10 and my 30. Then I'm going to subtract that 20 over, and I'm going to get 2x equals 20, because 40 minus 20 is 20. Then I'm going to divide both sides by 2 to get x equals 10, and I have x equals 10 down here. A lot of times it'll ask us to find x. Sometimes it asks us to plug that back into the top equation to find out what that angle equals. So you would say 2 times 10 is 20 minus 10 is ironically still 10, because that's just the way this problem works out. Here, we can take that one step further and say, if and only if that middle segment cuts the line in half, we can say it is a midpoint. If you ever see if written with 2 F's, it means if and only if. So under no other circumstances will it be considered a midpoint. It has to cut the line in half. So if that was the case, line AC, or segment AC, would be equal to segment BC. And you can solve it a different way. You don't add them together to get the whole. I mean, you can, but you can also divide it to get one side, or you can subtract to get one. So the midpoint theorem kind of takes it one step further. It takes that, well, I know this side plus this side equals the whole thing, but what if they were equal? Well, now I can find one side and automatically know the other. I don't have to figure anything out, and I can find the whole just based on one side. So using your brain to take it. Again, simple adding parts together, finding missing parts, and now we're able to look at it in different contexts. And now I'm going to go over the exact same things with angles. Here we go. I swear, the computer does not want to work with me. I need to turn scrolling off. Angle addition. That would make things a little more difficult, though. I don't know. Angle addition. Same thing as segment addition. So saying that I have angle ABD and DBC, adding those together because they share that ray is angle ABC. Ta-da! Very same thing we kind of talked about here. So let's make this a color and make that stand out a little bit from our other. Let's make it blue, so because the other one's green down below. So my formula is the measure of angle, or if BD intersects ABC, so it cuts through the angle right there. Angle ABC is the same as ABD plus DBC. It's trying to correct that to ABC. ABD, DBC, ABC. This part plus this part equals the whole. Angle addition theorem. Isn't it crazy that people had to discover this stuff along the way, because it wasn't just kind of common knowledge, because humans invented angles. This is what they meant in that video by, like, I'm assuming this is what you guys meant when all of you commented, all math is found, even though that's not what he was saying in the video. Pay attention. All math is found. Yes, all the math that they've done so far has been discovered by someone. Yes, all math has not been found because we are still, there's actually just in the past couple of years been huge advancements on the chaos theory, which is a neat thing we might talk about at some point this year just for posterity's sake. So here we are at missing pieces and postulates. We also have the definition let's finish this problem first. So if I have my examples up here, so ABC, the entire thing is 70, the small angle is 4x, and the small angle is 3x. So I can say 4x plus 3x, my two small angles, add together to get 70. I can take it one step further and say 7x equals 70 because I'm adding my like terms, and then I have 10x. So I'm taking the facts that are from the picture and putting it into numbers. I'm taking geometry and turning it into algebra. But that is kind of the idea behind how you can use that theory to find out missing parts, not just the whole shebang, not the whole angle. Also, if you have one and the whole, you can subtract it to find the other. Again, you're manipulating these formulas to work for you. Just like we had our mid-segment, we have a bisector. A bisector cuts an angle in half. So instead of it being, so if and only if the ray cuts it in half to two smaller angles that are equal to each other, will it be considered a bisector. But if it tells you it's a bisector, you know that the two angles, that the two adjacent angles are in fact equal. They are congruent, they are equivalent. So that kind of helps with that. I hope that helps understand a bit about lines and angles. So, but Miss Monroe, you said we were talking about triangles today. Yes, we are. There are segments and angles in triangles, so we had to go over that before we, yeah.